For 6.3, we are asked for which values of x is f of x minus g of x less than or equal to 0. Now, if we look at this question, what we need to do is to take g of x other side. So this would be f of x is less than or equal to g of x. It's equal to g of x. So now, for us to answer this question, what we need to do, we need to find out what are we talking about when you say f of x is less than or equal to g of x. Now, less than would mean that the graph of f must be below or equal to the graph. And where can we find this? First of all, over here we have an extension of this function. It continues up until infinity, and this would be g of x. Well, let me just write g, and over here would be the graph of g, and over here would be the graph of f. So now, these graphs intersect at the point -2, and at the point x is 3. But we know that if we go to the right of -2, actually f would be, or g would be below f. G would be below f, as you can see. And then if you go to the left of -2, g is above f. So meaning this is what for g is, and here's g on. Then meaning that is x is less than or equal to -2. Then when we go to the right, it doesn't hold. Then now these two functions intersect at x is equal to 3. If we go to the left of x is equal to 3, this would be g, and then this would be f. But we can see that f is above g. So that's not what we're looking for. We're looking for where f is below g. And then when we go to the right, of 3, we can see that the graph g is above f. If we can continue here, it's above f, or f is below g. So here's f at the bottom and then g at the top. So meaning that another answer would be x is greater or equal to 3. So that was a very simple answer. Then the last question is we need to determine the maximum length of CD. So we have CD here. It starts from C and goes to D, and this is the line CD. And we need to find the maximum length of CD. Now, this is a question that you would realize for calculus, because at this point we have the graph of f, and then at this point D we have the graph of G. And these two graphs, if we want to find the distance of CD, we would say that the y value of f minus the y value of G. And the y value of f is what? Is given by the equation -3x squared minus 9x plus 30. And then the graph of G is given what? -12x plus 12. So now we need to find the distance And if I can write it here as 6.4. So here's my 6.4. CD is equal to f of x minus g of x. And f of x is negative 3x squared minus 9x plus 30. So it's minus 9x plus 30 minus, then g of x is negative 12 plus 12. So here it is negative 12x plus 12. Then what we can do, we can simplify this as negative 3x squared minus 9x plus 30, then distribute the negative. So it's going to be positive 12x minus 12. Then now the equation of CD. The equation of CD, we are going to collect the like terms. So when we are collecting the like terms, we have negative 3x squared, and then we have negative 9x plus 12, which is going to give us a positive 3x, and then we have 30 minus 12, which gives us a positive 18. This is the equation of the distance. But now if we want the maximum distance, what we need to do, we need to make the derivative of the distance equal to 0. Then we can find the maximum. So the derivative is going to be negative 6x squared plus negative 6x, in fact negative 6x, because we're going to take the 2, multiply and subtract 1 from the 2. So it's going to be negative 6x plus 3 is equal to 0. Then meaning negative 6x is equal to negative 3. Then x is equal to 1 over 2. So we have the maximum distance at x is equal to 1 over 2. Then what we need to do now, we need to substitute the 1 over 2 at the distance formula. So now the distance formula is that the distance of CD is equal to this. So meaning that CD is equal to negative 3x squared minus 3x plus 18. This is the formula for the distance of CD. Then now what we are going to do, we are going to substitute negative. So this is going to be substitute negative 3, 1 over 2 squared minus 3, and then we have 1 over 2 plus 18, and then we have now the actual distance, which is 75 over 4. But in essence, once you have the distance as a formula, this is a quadratic, and what you can do, you can find that point. But we know from calculus that at the turning point, the derivative of a function is equal to 0. Hence now we are doing the derivative of this function, and then we find x, and then substitute x on the function, and then the distance is 75 over 4. So that's it for question 6 on the parabola. Now we can do the mark allocation. Allocation for 6.1. 6.1 is worth 4 marks, and you get a mark for equating to 0. You get a mark for the factors, and then you get a mark for the x values, and then you get a mark for 7 units. So 4 marks. Then for the point of intersection 6.2, you get a mark for equating both equations. You get a mark for the standard form, whichever standard form you use, and then you get a mark for factors, Whether you used a quadratic, you'll get a mark for substituting, and then you get a mark for x values and get a mark for the y value of 24, and together that is 5 marks. 6.3 is out of 3, so you get a mark for, you get 3 marks for the inequalities, so that is 3. And then 6.4 is, it's 5 marks. Let me go back here. 6.4, it is actually 5 marks. It's 5 marks. So if you look at our answer here, x is between negative 2 and 3, and value our answer, which is 1 over 2, is between negative 2 and 3. You get a mark for substituting the distance formula as what, as subtracting the y values, and then you get a mark for the standard form. You get a mark for whether you found the turning point or you let the derivative equal to 0, and then you get a mark for x is 1 over 2, and then you get a mark for the y value, and all in all that is 5 marks. The next question that we are going to do is calculus. Okay, so for question 7 we have calculus, and the first question is first principles, and we need to find the derivative of 4 over x from first principles. And now you remember that the equation for first principles is that the derivative or the gradient of a function is equal to the limit of h approaching 0 of f of x plus h minus f of x all over h. Then now we'll have that the derivative is equal to the limit of h approaching of what? F of x plus h, we just simply put 4 over x plus h, substituting x plus h on f of x minus 4 over x. So that is very simple. And then this is divided by h, so meaning that the limit of h approaching 0 is now what? 4 over x plus h minus 4 over x all over h. So now we can simplify this and say limit of h approaching 0 is now, what we are going to do is find the LCD here, which is now going to be x multiplied by x plus h over, then cross multiply here, it's 4x minus 4 times x plus h. And to yourself here, what I did, for me to find LCD, the denominators and then cross multiply. So now me multiplying the denominators, I get x multiplied by x plus h, and then I get 4 by x, which is 4x, minus then this 4 multiplied by x plus h, and all of this is divided by h. So now I have limit of h approaching 0 is now equal to, in the numerator I have 4x, and then I will distribute the 4x here, minus 4x minus 4h over, I'll have x times x plus h, and then this is going to be divided by h. So I don't want to simplify my numerator because it might cancel out, or my denominator, so I don't want to rush things. But now limit of h approaching 0 is now equal to this 4x and this 4x cancel out, so I will be left with negative 4h over x squared plus hx, and then now I'm going to change this to multiplication and then flip this to 1 over h, and then now h and h cancel out. Then now the limit of h approaching 0 is now equal to negative 4 over x squared plus 8x. Then I stop writing limit and substitute 0, so negative 4 over x squared 0 times x. Therefore now the derivative is equal to, and where do I get negative 4? Is it negative 4? Because it is negative 4. So this is negative 4 over x squared. So that's our final answer. So yeah. So that's how you find the limit or the gradient using first principles. The next question is 7.2. 7.2, we have 2.1 and 7.2.2, and we need to find dy dx if y is equal to, and then these questions are using differentiation rules. Then now we know that we can just take the exponent, multiply the coefficient, and then subtract 1 from the exponent. So meaning we can go just go straight to dy dx is equal to, then 5 times 2 is 10x plus 5. I think that is very simple. 7.2.1, we have dx. So now we need to first simplify the bracket over here. So dx is now what? X to the exponent 2 over 3, because we know that if you have a to the or root n, or n root a to the exponent m is now what? M over n. So now it's going to be 2 over 3. Then now it's minus over 2x. Then we have simplified, and then now when we differentiate, we are going to multiply x by 2 over 3. So that will be 2 over 3x. And when we subtract 1 from 2 over 3, we get a negative 1 over 2. And then when we multiply by 1, it stays the same here. 1 over 2, and then subtract 1 from 1, which is, it's going to be x to the exponent 1. Now the answer is 1 over 2. And if you want to use positive exponent, this is going to be 2 over 3. Let me just create space here. It's going to be 2 over 3 x to the exponent 1 over 2 minus 1 over 2. So that is very simple there. The next question is 7.3. 7.3 is asking us to show that it is not possible for a tangent to the graph of x to the exponent 3 plus 2 to have a negative gradient. So we know that this is p of x. So let me just label this as 7.3. P of x is equal to x to the exponent 3 plus 2x. Then now, the gradient, the derivative, equal to 3x squared plus 2. So we need to prove that this can never, the function can never have a negative gradient. So the equation of gradient is squared plus 2. So now, this is the equation of a gradient. Every time when we substitute x, if we substitute x, this will be squared. Even if x maybe is negative 1, negative 1 squared is a positive 1. Negative 10 squared is a positive 100. So every time when we substitute, because of 3x squared, this can never be equal to a negative number. So meaning that the 3x squared will always be greater than 0. Therefore, and when we add plus 2, it makes it worse. It will never be equal to 0. So meaning that the tangent will always have a positive gradient because of the term 3x squared is always going to be greater than 0. So how can we write this? It's either the functions or the tangent, the gradient of the tangent will always be greater or equal to 2. Or equal to 2, because the smallest value we can substitute here is negative infinity, but we are going to have a positive number multiplied by 3. But if you substitute 0, that's the minimum we can substitute is 0. Then the gradient will be equal to 2, meaning the gradient of the tangents to the functions will always be greater or equal to 2. So that's a very simple question to answer, and that brings us to a conclusion of question 7. So we can do the mark allocation here. For the first question, first principles is actually 5 marks. You get a mark for the formula. There's a formula. You get a mark for substituting to the formula. You get a mark for simplifying the numerator by creating an LCD, and then simplifying after the LCD, and then you get a mark for your final answer. That is 5 marks. Then for 7.2, 7.2.1, in fact this is 0.2. 7.2.1, you get a mark for differentiating the first term, and differentiating the second term is another mark. So that's 2 marks. And then 7.3 now, you get a mark for making or finding the derivative, and then you get a mark for making the derivative equal to 0. Oh, you make the derivative, you get a mark for the derivative, and then also you get a mark for stating that every every gradient is equal to is greater or equal to 2. That is 2 marks for the reason. So in total it's 3. Then our next question is question 8, and we are dealing with the derivative of a cubic function. Okay, so for question 8, we are given the graph y is equal to ax squared plus bx plus c, and it's representing the derivative of f. So it's not actually a function, is the derivative of a function, and it is given that the derivative at 1 is equal to 0, the derivative of the function, and the derivative at 3 is 0, and then now the derivative of the function at 0 is 6. So meaning that now, because this is the derivative, we can say this point here is 6. Fine. And then now, because the derivative, this is the graph of the derivative, and the graph of the derivative at 1 is 0, so this would be 1, and then the derivative at 3 is 0, so this would be 3. So we have that information. This gives us the x-intercept of the derivative, and then this gives us another x-intercept of the derivative, and then this gives us the y-intercept, the derivative, not of the function, of the derivative. So the derivative of f of x, f of x, because the derivative in and of itself is a function, so it's the function of the gradient. So now let's look at 8.1. 8.1 says write down the x coordinate of the stationary points of f. Now if we're looking at x versus the derivative of f of x, what we call the x-intercepts of the derivative will be the turning point actual function. So meaning that now, if we want the stationary points or turning points, so stationary turning point, if we have the x-intercept of the derivative, that means our stationary points of f of x. So meaning the x-intercept of the derivative is 1 and 3. So meaning the answer is x is equal to 1 and x is equal to 3. Very simple. Then 8.2, for which value of x is f strictly decreasing. Now if we look at the function of the derivative, the function of the derivative is decreasing between, in fact, let me just create a symmetry. The symmetry here is what? Is this point here. But now, if we are talking about the function of the inverse, the function of the inverse can be what? Can be positive or negative. So if we to look at here, this area here, the inverse, or not why am I keeping saying inverse? The derivative, in fact, the derivative is negative. So if you look at over here going this way, the derivative is positive, and going this way the derivative is positive. What makes a function decrease? It's a negative derivative. Now the graph of the derivative here in the yellow space is negative, so meaning that the derivative negative. How am I saying it's negative? If you look at the x-axis, values, y values that are above the x-axis. Let me write values and not confuse you. Y values are positive here, and then when you go below the x-axis, y values are negative. Now, what makes a function f decrease is if it has a negative gradient. If it has a negative gradient, and you can see that in 1 and 3 the function of the gradient is negative, so meaning that the function is decreasing where x is between 1 and 3, because this is the graph of the gradient. Remember, this is what they said, represents the derivative, so meaning the derivative of the function f, and this is called the what? The gradient. So now, if a function has a negative gradient, and the negative gradient is between 1 and 3, then the function will decrease. But now, if we go to the left of 1, the function here is on the positive y-axis. If we go to the right of 3, the function here is on the positive, so meaning the function will increase after x is equal to 3 and will increase before x is equal to 3. But between 1 and 3, this function is below the y-axis. This function is negative. So now a negative gradient gives us a what? A decreasing function. So very simple there. Then 8.3. Explain which values of x, the stationary point of f, will be a local minima. Now, if we're going to find out which values of x, we need to look at whether a is positive or negative. Now, for the stationary point of a function, so for us to know that a stationary point is a local minimum or a local maximum, we need to find out whether a function starts by increasing, right, or starts by decreasing. And you can see that between the stationary point, these are the stationary points, the function starts by increasing. If it starts by increasing, it will have a maximum. Then if it starts by decreasing, it will have a minima first and then have a maximum. But how do you find that out? You can see that at the start of the function, if you look at the function over here, it starts by increasing because the gradient is positive. How do we see that? Because the function gradient is on the positive y-axis, so meaning that this is what we need to look at. Then the first value, x value, is 1. Then the second x value is 3. So meaning that now the function starts by increasing, then decrease, and then increase again. So it starts by increasing, then decrease, and increase again. This is what we are seeing on the function. The positive function gives us the first increase. Then the negative function, the yellow area, gives us a decrease, and then the positive function again gives us an increase. So we have case number 1. This is case number 2 doesn't apply because the gradient doesn't start at negative. If it was starting at negative, then our function would look like this, because this is the function of the gradient. So meaning that now the first x value would be the maxima, and then the second x value would be the minima. So now how are you going to explain this? You are going to say that first of all, x is equal to 3. Why is x equal to 3? It's because the function, the gradient of the function changes from a positive to negative. Therefore, or you can say that the a is greater than 0. So a is greater than 0, then the function starts how did I write start now? Starts by increasing what's wrong with my stylus? Increase towards the maximum. Starts increasing towards the maximum. In second, x value is the minima. So that's how you answer 8.3. Then 8.4, it says that determine the coordinates of the point of inflection of f. Now the point of inflection of f, we have generally stated that these 2 points are the x values of the gradient of the function, but they are the stationary points of the actual function, meaning that now the axis of symmetry, the axis of symmetry or the turning point is going to be the point of inflection. So meaning that what we can do is find the distance, the midpoint of the x values, then this will give us the point of inflection. So the midpoint of the x values is now going to be 2, because this is 3 plus 1. This is 3 plus 1 divided by 2, which is equal to 2. So that is very simple. What do you need to know when it comes to the relationship between the function and the graph of the inverse is that with the graph of the inverse, the x-intercepts are the x values of the turning point of the actual function. Then when you go to again f of x versus g of versus the derivative of f of x. Remember, we already discussed that the x-intercept of the derivative are the stationary points or turning points of the function. Now we need to discuss the turning point of the derivative is the point of inflection of the actual function. So if they are asking for the turning point of the function, you can use the x-intercept of the derivative. If they are asking for the point of inflection of the function, you can use the turning point of the function, and you can use axis of symmetry because that is the midpoint of the two x-intercepts. So that is very simple. Then we can go for mark allocate 8.5. 8.5. And for 8.5, for which values of x will the function be concave up? And that means we have to get a value that is greater than the point of inflection, which is x is greater than 2. So that is very simple. Because we are dealing with what the second derivative must be equal to the second derivative of f of x must be equal to 0, and we know that that is the point of inflection, so we have to get a value that is greater than the point of inflection, which gives us a concave up function. So that is very simple. And then for mark allocation now, 2 marks for 8.1, you get 1 mark for x is equal to 1, x is equal to 3, and then x 8.2, you get 2 marks for x is between 1 and 3, that is 2 marks. And then 8.3, you get a mark. Wait, 8.3 is when we were finding, we had to explain which values of x will the stationary point be at the minimum. So this question is 2 marks. So you get 2 marks for saying that this is x is equal to 3, and then why is it x is equal to, because a is positive and it starts by increasing towards the maximum, then the minimum. So the second x value is the minimum. Then we go to 8.4. 8.4, we needed the point of inflection 2, so you get 1 mark for that, 1 mark. And then for which values of x will the thing be concave up, you get 2 marks for x is greater than 2, so that is 2 marks. So that is it for question 8. And the last question is question 9, which is the application of calculus and is optimization. Okay, so our last question is the application of calculus, and we are doing optimization. And we are told about the mass of a baby in the first 3 days of life is given by that formula there. And you can see that t is between 0 and 8. And this means that if they're saying this is time days, this means it's from birth until the first 30 days. Then m is the mass of the baby. So now we need to answer these couple of questions. And for 9.1, we need to write down the mass of the baby at birth. And we know that at birth, the baby has 0 days. So this is m at 0 is equal to 0 to the exponent 3 minus 9 times 0 to the exponent 2 plus 3,000. Then now we can see that the mass of the baby at 0 is equal to 3,000. And this is 3,000 grams. Fine. 9.2 says that a baby's mass usually decreases in the first few days after birth. On which day will the mass of the baby return to its birth mass? So meaning that if we have the equation of the mass of the baby, which is t to the exponent minus t to the exponent 2 plus 3,000, then we need to know when does it return to 3,000, meaning there are 2 days or 3 days or 4 days where the mass of the baby is 3,000. So what we can do now, take the 3,000 to the other side, it becomes t to the exponent t minus 9t squared is equal to 0, because these two are going to cancel. Then now the common factor is t to the exponent 2 and now we have t minus 9 is equal to 0. So we'll have t squared is equal to 0, meaning we can root both sides and then t is equal to 0. Then now the next one we can have is t, or t minus 9 is equal to 0, so meaning that t is equal to 9. We have 2 days, the day at birth and the ninth day. So at the ninth day, the mass of the baby is also 3,000 grams. So very simple. That is very simple. So meaning on the ninth day. So it means on the ninth day. Very simple. Then 9.3. On which day will the baby have a minimum mass? So guys, for this type of questions, please, what you need to do whenever there's a minimum, maximum, we know that we must let the derivative equal to 0. So for the derivative, we have that m in terms of t is equal to t to the exponent 3 minus 9 times t to the exponent 2 plus 3,000. Then we know we must find the derivative of t, which is equal to 3t. I'm so addicted to x. So this is 3t squared minus, this is going to be 9 times 2 is 18. So we are going to let 3t squared minus 18 equal to 0. So meaning 3 equal to 18, then we divide. In fact, the derivative, yes. So this is 3t squared is equal to 18, and then now we're going to have a common factor here. In fact, let me not ruin things. We're going to have a common factor of 3 here. So meaning that for us to find the derivative here, the common factor is, what did I do here? Let me just start over. So we are going to say this is 18t. Yes, it's 18t. I can see where I went wrong. And 3t squared minus 18t is equal to 0. Then we can take out a common factor of 3t. So this is 3t common factor. And then meaning this is t minus 6 to 0. Yeah, there we have it. Then now we know that 3t is 0, or t minus 6 is equal to 0. Therefore, t is 0, or t is equal to. So now, what was the question asking? When will the baby have the minimum mass? Fine. So we can say that the baby will have the minimum mass where on the 6th day. So that is very simple there. 9.4, the last question, 9.4. On which day will the mass, or the baby's mass, decrease the fastest? Now you remember that we have the point of inflection. The point of inflection, depending on the function, this is where the function or the gradient of the function will either be at the minimum or at the maximum. So when they talk about decreasing the fastest, remember what makes a function decrease is the gradient, and how big the gradient is, or the the magnitude of the gradient depends or dictates how fast the baby's mass decreases. So we need to find the point of inflection over here, and we know the first derivative here is equal to 3t squared minus 18t. Then we need to find the second derivative. I'm just going to keep up with f of x, but if you like, you can just, this is m of x, but I'm used to x and f of. So now the second derivative is going to be 6t minus 18, and then we're going to make 6t minus 18 is equal to 0. Then 6t is equal to 18, then t is equal to 3. So that now on the third day, the mass of the baby is going to decrease the fastest, which is the point of inflection, and that we conclude our mock exam. So just for mark allocation, we have 9.1, which is 1 mark, so you just get 1 mark for the answer. And 9.2 is 4 marks, so you get a mark for equating to the baby's initial weight, or initial mass, in fact. And then the next question, you get a mark for the derivative equal to 0. You get a mark for factorizing, and then you get a mark for the answer. So in total, this is 4 marks. Then for 9.3, which is also 4 marks, the first mark that you get for making the derivative equal to 0, or finding, also a mark for finding the derivative. Then you get a mark for factorizing, and then you get a mark for the 6 days, and then that is 4 marks. Then when you go to the last question, which is 9.4, you get a mark for making the second derivative equal to 0, so which is actually here. Second derivative is equal to, and then the answer, and then that is 2 marks. I do hope that you enjoyed the doing the question paper with me. I know we had some minor hiccups, but we started in class, and which was a beautiful session. It was an active session, and I do hope that you'll keep watching the videos. But just remember to like and also subscribe, so that it will also encourage me to make more videos. So I'll see you on the other video.